Okay, everybody, this is just so strange. I don't know why I'm having these technical issues, but anyway. Okay, take this question here. This is the backside of your handout. What I want you to do, oh, we have to cross this out, everybody. Cross out part C. We can't do it yet. Cannot cross out part C. But you can certainly do A and B on your own. So please do those and then meet me or restart me so we can compare answers and make sure you all did that correctly before we go to part D, okay? Okay, everyone, here's part A and B. A and B are fairly straightforward. Let's see. So here's A, here's, dy dx, here's d squared y by dx squared. And notice here that you be careful with the implicit differentiation. There's a dy dx here. And ordinarily, I would go and put dy dx, like this entire expression, back in here. But it's not asking me to do that, first of all. And secondly, I have to evaluate the second derivative at -1, -4. And that's really great because I already took care of this value at -1, -4 above. So I just plop that into here, okay? Be careful, you know that I'm picky about this, right? There is your dy dx, your derivative when you're inputting a particular value, and then there's your general derivatives, right? If you're not inputting a particular value, don't say you are. See, notice what I'm doing over here, and then being really clear when you're inputting a value. Okay, very good. B, I love question B. It says, is it possible for the x-axis to be tangent to the graph of f at some point? Explain why or why not. And all I did here to kind of make this more clear to me, aka you, is really the question's asking, is it possible for the slope of the line tangent to the function to equal 0 at y equals 0, and y equals 0 is nothing other than the x-axis, correct? And if this line, this horizontal line, the x-axis, is tangent to this function, then at that point of tangency, dy dx would equal 0. So let's see what we did. I just found what dy dx at y equals 0 would be, right? We don't know what x is, so that should remain an x. And the question is, can this slope ever be 0? And you see that there is no way for it to ever be 0, because when you go ahead and try and find possible x values that would yield a horizontal slope or a point of horizontal tangency, it doesn't work, right? Because right here, this equation does not yield any real solutions. You see how I kind of put that back in at the very end there. I caught it. All right, now we're on to part D, the Euler's method. So it says here, use Euler's method starting at x equals -1, and x equals -1, we'd have that point, right? X equals -1, y equals -4, with 2 steps of equal size to approximate f of 0. This is an interesting phrasing, right? So they're telling you they want you to use Euler's method twice, right? 2 steps of equal size. That's what it means there. 2 steps of equal size to get me from x equals -1 to x equals 0. They don't explicitly tell you what the step size is. They don't explicitly tell you what dx is, but you could figure it out, because if you're starting at x equals -1 and you want to get to x equals 0 and you only want to use Euler's twice, what would the step size be? Yes, very good. Delta x would equal 1/2. In case you're wondering, delta x is not always going to equal 1/2. That's just a coincidence. So what I'm going to have you do here is go ahead and finish Euler's, do it out, or part D, and then reply me for the answer. Okay, here I am, and what I did was I just solved the differential equation for dy. Be careful, you have to take this dx, you multiply it, right? Just simple algebra here. Dx is 1/2, I just plugged it in, plugged it in, plugged it in, plugged it in. I got to -0.5, -1. I did Euler's again, all the way through, and I got 13/8. At the end of the day, I want to make sure I explicitly say to the reader I understand that I've just used Euler's to approximate f of 0, which is approximately 5/8. I wonder if I made a mistake somewhere in my arithmetic. What do you think? Did I? Let me see. No. Uh-oh. Oh, no. Oh, no. Oh, no, no, no. 5/4. 2. Okay, well, all right. That's funny. All right, good. So apologies for my handwriting not being as neat as Mason's. Mason Tomlin, you have the most beautiful handwriting. And knowing Mason, he probably just gave me a look or gave the screen a look and just like casually but coolly rolled his eyes. But Mason does have very beautiful handwriting. I strive. Okay, everyone, great job. So what I'm going to do is post the homework on the teacher page, and thanks for the broken up pieces of this screencast. I think I figured it out, though. It's because I had not updated this software. That's what happened. All right, goodbye, everyone.